Yeah, good evening all. Right, in the last class, just I was briefing you about big data Hadoop, why Hadoop drawbacks, current databases, Hadoop and PySpark advantages, and Hadoop and PySpark job market. So databases. So we have got big data like huge volumes of data. So we have got databases like Oracle, MySQL performing OLTP operations, and we have got specialized databases like Teradata, Netezza, right, for performing OLAP operations. But they can handle data up to some extent. But for huge data, unlimited data storage and processing, we go for a Hadoop, right? Hadoop performs both storage and processing. That too, unlimited data storage and very high speed processing. So for storage, we use HDFS, and for processing, we are going with MapReduce or Spark. So Hadoop is only for Hadoop is for batch applications. Batch applications. Hadoop is not for online applications. Batch application online. There are two types of applications. Online applications, user interactive applications. User gives the input here. Booking a movie ticket, transferring amount through online. And here, batch applications, user non-interactive applications. Here, user is no way required. User is no way required. Railway ticketing, PNR status, generating credit card statements for millions of customers. Okay, why? Okay, drawbacks with the current databases, limited storage in most of the databases, no parallel processing. If volume increases, speed decreases. If complexity increases, speed decreases, right? If complexity increases, speed decreases. And major drawback, databases can handle only structured data. They cannot handle unstructured or semi-structured kind of data, right? Yes. Hadoop doesn't follow client-server architecture. Hadoop doesn't follow client-server architecture. Hadoop follows master-slave architecture. Hadoop follows master-slave architecture, right? Yes. Hadoop cluster, group of nodes connected in a network. There are two types of nodes, master and slave node. Master node responsibilities, assigning task, load balancing, fault tolerance. If any if any system fails, then the task of it has to be assigned to the other slave. This is done by master. Slave node responsibilities. Storing data and processing data, right? Storing data and processing data. Hadoop advantages, unlimited data storage because of horizontally unlimited scalability. Horizontally unlimited number of slaves can be added. Very high speed processing because of parallel processing. Can handle all varieties of data, structured, unstructured, and semi-structured, commodity hardware, anything, right? It doesn't mean that you need to have highly configured, no, and no licensing required. Yahoo has taken a table of 100 TB consisting of 1024 columns. Task, sorting based on 16 columns. Sorting based on 16 columns. Time taken by different databases. Time taken by different databases. Oracle has taken 3.5 days. MySQL has taken 6 days. Teradata has taken 4.5 hours. Netezza 3 hours. Hadoop has taken 3.2 minutes. And latest version of Hadoop has taken 1.4. Spark is only Hadoop, very high speed, right? Hadoop has got very high speed as compared with the databases. But if we talk with Spark by Spark, 100 times faster than Hadoop. See the speed of that Spark there. Why databases like Oracle can't store unlimited data? Means databases has got some limit on the number of slaves. Like if you talk Oracle, MySQL Express, SQL Server, all these databases stores up to 256 can support up to 256 slaves systems, right? Nodes. But Teradata and Netezza Vertica, Teradata and Netezza currently going with 1024 slaves. CPUs nodes to Vertica going with 512. But there is no limit on the number of slaves that Hadoop can have, right? Hadoop can have unlimited number of slaves we can keep on adding, right? Yahoo when first time implemented Hadoop. Yahoo when first time implemented Hadoop went with 4,000 slaves. Currently going with 12,000 slaves. Currently Yahoo going with 12,000 slaves. Facebook when first time implemented Hadoop went with 8,000 slaves. Currently, they are going with 42,000 slaves. And Facebook currently going with 42,000 slaves. Means there is no limit on the number of slaves that Hadoop can have, right? Hadoop ecosystem components. HDFS for storage, MapReduce for processing, Hive also for processing. We use HQL, which is similar to SQL. Scoop for import, export, NoSQL, right? Database for schemaless behavior and random access. HBase, Yarn, yet another resource negotiate drawbacks of the previous versions were rectified here. Zookeeper controls and coordinates all the other Hadoop components, right? Flume Kafka for live streaming data. This used for live streaming data. PySpark, Spark Core, Spark SQL, Spark Streaming, and Spark ML libraries. Okay. I was discussing about Spark, right?
Hello, sir.
Very high speed processing. Yes,
Can we have any drive shared with us where the recordings are there?
yes, yes. So if you already got enrolled, right, check your Google Drive, share it with me option. Check
Okay.
your, if you already done with the enrollment process, you can check your Google Drive. That Google Drive, they'll be shared with me, it will be there. In that you can see the videos, right? Yes. So yes, yes, 1 second, right. Today I'll forward you these notes, whatever I'm discussing, right? And also the software I'll provide to your Google Drive. Okay. So what is Apache Spark? Why PySpark? Need for PySpark, right? So Spark is an open source distributed cluster computing introduced by Apache Software Foundation. It's a general engine for big data analysis, processing, and computation. So it's a Python API to use Spark. What is that? PySpark is what? Python API to use Spark. So PySpark is the lightning fast technology that is designed for fast computation. It's one of the most demanding tool among data engineers to work with bigger data sets and getting the results in quick time. So mostly used for PySpark for running distributed SQL, creating data pipelines, and also running ML algorithms, working with graphs or streams, right? Need for PySpark, you see like huge amount of data generating. This data consists of hidden patterns, unknown corrections, market trends, and from that we need to extract the useful information, right? So we require some tools for performing multiple tasks on very huge data sets. So, so PySpark is such a kind. So combining Python and Spark will be the efficient way, right, of big data, right? So yes. How exactly the data storage and processing is happening, right? In this Hadoop. Just observe this. How exactly data stored and processed? Data stored and processed. How exactly data stored and processed within Hadoop? Okay, just observe this once. In Hadoop, data is stored in the form of files. Data is stored in the form of files. .txt files, okay, or .csv files, .json files, .xml files. Right. Data is stored in the form of files. Each file is again subdivided into blocks. Each file again subdivided into blocks. Each file subdivided into blocks. Default block size 64 MB, but in the latest version 128 MB. Means if you got a file, it is divided into blocks. Default block size now currently 128 MB or 64 MB, anything, right? In the latest version, it will got 128. Assume you got f1.txt file. Notes I'll be forwarding today. You can see that videos, right? Videos are available. Notes I'll forward you today. So those for those what enrolled, you are
Sir,
got
actually, it's not shared with my drive, sir. I'm already enrolled.
videos.
No, not shared.
Videos are not shared.
Yeah. Actually, drive is not shared with me. I'm already enrolled.
1 second. Okay. Okay. So by the end of the session, you can just observe it that I can see that within your Google Drive, right? Okay. Observe. In Hadoop, data is stored in the form of files. Again, the file is subdivided into smaller parts called blocks. Default block size. Assume you got a file f1.txt. The size of it 200 MB. The file size is 200 MB. Assume that you got some telecom data in it. So default block size, assume it is 64 MB. Default block size, assume it is 64 MB. Into how many blocks the file is divided. This 200 MB file divided into how many blocks? File size by default block size. 200 by 64. Totally nearly 4 blocks you get. Assume B1, B2, B3, B4. We got 4 blocks. Each block of 64, 64, 64. Last block 8 MB only stored. 56 MB free in the last block. 4 blocks stored across 4 systems. Okay. In Hadoop, data is divided into blocks. Each block is distributed across The blocks are distributed across multiple slaves. This is fine. F2.txt. Observe this F2.txt. 192 MB. What data? Banking data. USD telecom data. Now this is what? Banking data. Number of blocks. File size by default block size. Number of blocks equal to file size by default block size. File size is 192 by default block size 64. Totally 3 blocks for f2.txt. Assume B5, B6 and B7. B5, B6 and B7. These 3 blocks stored in 3 different slaves. Here I got a query. Why this B5 data is not stored in B4 when B4 has got 56 MB free? Understand this? Why B5 data is not stored in B4 when 56 MB is free? Assume if B5 data is stored in B4, assume if B5 data is stored in B4, I want to retrieve this f1.txt. Why B5 data is not stored in B4 when 56 MB is free means, assume I want to retrieve this f1.txt. If you want to retrieve this f1.txt file, b1 plus b2 plus b3 plus b4, b1 plus b2 plus b3 plus b4. If b5 data stored in b4, b4 8 MB plus 56 MB extra you will get of f2.txt. But actually the file size was 200 MB, but you got a file size of 256 MB. 56 MB extra data you got of banking data. Whenever you're retrieving telecom data, a part of banking data you got within it. Actual file size should be 200 MB, which is a wrong computation. Hello, understood everyone? What is that? That's why every
Yes,
file
sir.
will have its own blocks. Every file will have its own blocks. If B5 data stored in B4 means, whenever you are retrieving the telecom data, you also get banking data. That's why every file will have its own blocks. Don't worry about the notes. Clearly, I have mentioned that notes will be easily understandable. I'll forward you this.
Sir, hello.
Yes.
If Hadoop is retrieving data from the disk, then the access time will increase.
If
If Hadoop is accessing data from disks,
from
hard
data
disk,
from
then access,
data
yeah,
from uh,
hard disk, not from the primary memory.
mm,
Then access time will increase.
yes, as compared with Spark, right?
Yeah.
Yes. But for Spark, we require huge RAMs. If huge RAMs are maintained, then you can go for Spark. Otherwise, we go for Hadoop only. Hadoop has got a high speed parallel processing. But today, like Spark is mostly preferred because of its very in-memory computation and very high speed processing. In-memory computation, memory level storage and processing.
Then how this Hadoop and Spark will have different from Hadoop is different with Azure data bricks and all, because it's also used as a storage engine.
Hello.
Hello.
Yes, yes. See, there'll be
Yeah.
on premises. On premises, it will be there. On premises, right? Whenever you want to
Yes.
create a cluster, whenever you want to create a cluster there. So here, within this on premises, if you want to create like we are going to create a Hadoop cluster. So there also will be using yarn architecture only. Here also will be using yarn architecture only. Yes, but okay, storage, okay, you will be using S3 bucket, but internally yarn architecture, okay, here will be using yarn, but in everything related to Spark will be same whenever you are running there or here. But Hadoop, now you are maintaining, increasing the cluster, right? You keep on adding nodes. There also will be creating clusters with different nodes. Yes,
Yes,
data will
means
be
in
shared.
Hadoop, means in
Yeah,
Hadoop horizontal scaling we always do.
yes, yes. Horizontal scaling,
Then
horizontal scaling.
then what is the difference between this Hadoop and the data lake which we are using in Azure platform?
So that's why that okay, whatever is Hadoop, in the Hadoop you will be learning something where you will be scoop, Hive. You'll be discussing what scoop, Hive components and NoSQL things, right? Where we'll be importing the data, exporting data, right? Bringing data to a single place. Okay, if you are using that Azure or AWS or this HDFS, right? Okay, wherever you are storing, then after storing, you need to how from where you are going to pull the data from different data sources, OLTPs from different databases, eventually like from databases or from files, you are going to bring the data and you are
Yes,
storing it one place. Later, how we are going to process by using Spark. Okay, if you are
yes,
using, okay, Hadoop, what is that? HDFS you can use, or if you are saying like any other storage systems, if you are using, you can use these days. You are using the other things also. You are using like Hadoop HDFS, right? And otherwise, if you are going with those, as you said, you can use those things. And later, the processing, like using Spark is just a processing component. It's not a storage, right?
yeah,
It's just how you are going to like PySpark, Spark with Python implementation. You are going to see how fast is going to get processed. Means it has got many built-in functionalities that all we'll be discussing, right? And also in Hadoop, as you know, there are some components which got outdated that I'm not going to discuss those, like
no,
MapReduce.
okay,
And we have got
no,
some
sir.
components which
Actually,
are
sir,
mostly, yeah, which are mostly used like Scoop, Hive, NoSQLs like HBase. Today, if you see most of the top 50 e-commerce sites, they are using NoSQL databases.
yes,
Top 50 e-commerce sites, they're using NoSQL databases instead of SQL databases, right? For storing their
yes,
data. So NoSQL means schemaless behavior, just like in SQL. SQL requires schema from first record to last record. We need to maintain the same number of columns. For example, product ID, product name, price. But in the case of NoSQL, record to record, different number of fields can be maintained. My first record with 3 fields, second record with 5 fields, third record with 10 fields, right? So they are mostly, that's what NoSQL databases, Scoop, Hive. These are the things which I am going to cover in Hadoop. Later, everything will be discussed on Spark, PySpark, Spark with Python implementation. Whatever required, what the industry is expecting. Previously, we have got many components like MapReduce, Apache Pig, which is also a data flow language, but those things are outdated, as you said. Now, but Hadoop and Spark combination, what are the things which you require from the Hadoop components, like importing, exporting from one source to other source, and from databases, how you pull data using these Hadoop components, and also like if you want to create some kind of data warehouse kind of environment, we use Hive, Apache Hive, right? Those things I'll be discussing. So here, okay, if you are using on premises, if you are using a HDFS cluster, you can maintain, or if you can use AWS like S3 bucket. So in this way, whatever the storage, right, you're using. But
Means in the sense, if we are using Azure Data Lakes or Databricks and Hadoop distributed system as a on-premise, both are one in the same.
so okay, Hadoop previously, okay, Hadoop now mostly we are concentration will be on PySpark. Some components of Hadoop, right? Like Scoop, Hive. Hive is also a kind of processing component for data warehouse kind of environment. So once you are storing, as you said, once you are storing data, right? Later,
Yes.
this processing components like Hive, the processing components like Spark, they'll take the input and they'll process again, they'll store the data back into this storage systems, whichever you are using. Okay,
Okay.
1 second. So, but how the data is getting stored means in the form of files. Here in Hadoop, everywhere you see the data in databases, how data is stored in the form of tables. But here data is stored in the form of files. The files again are subdivided into blocks. The blocks are distributed across multiple systems. Yes. So here, uh, every file will have its dedicated number of blocks. Right. Design principles with respect to HDFS blocks. Every file will have its dedicated number of blocks. File 1 will have its block. File 2 will have its blocks. File 2 will have its blocks. In a single block, in a single block, no two files data to be stored. In a single block, no two files data to be stored. All the blocks will have equal volume. All the blocks will have equal volume except the last block. Observe here. All the blocks will have equal volume except the last block. All 64 MB, 64, 64 except the last block. Okay. See the design principles. Every file will have dedicated number of blocks. In a single block, no two files data to be stored. All the blocks will have equal volume except the last block, right? These are the design principles with respect to HDFS. So by default, it is 128 MB in the latest version, the default block size. Previously, it was 64. But if you want to keep your own block size also, yes, I want to have my own block size. The file has to be divided into 100 MB blocks or 50 MB blocks. Yes, that also possible. How we can configure means go to Hadoop installed folder, go to the Hadoop installed folder, right? Configuring, increasing or decreasing the block size. Go to the Hadoop installed folder. In that, you can see conf folder within this Hadoop. In that hdfs-site.xml, there'll be an XML file. This file will be an empty file. By default, this file is going to be an empty file. Okay, this file. In that, just write this 4 lines, right? Configuration/configuration, opening and closing. property and slash property. What are the property? Name, DFS dot block size. Close that name. Value, what is the value for block size? 50 MB.
Sir, default block size is 50 M, sir. Can I give more than 50 M?
More than
50 M? Is it
50,
possible?
50 M means 50 MB.
Yes, sir. No. 50 MB is the default block size, sir. Or can I give more than 50 MB? Is it possible, sir?
The default block size is 128 MB currently, latest version. The previous version it was 64 MB. Even we can set our own block size. By default, 128 MB. If you are not giving anything, right? This configuration, if you are not writing in the Hadoop installed folder, you will see this file. It will be an empty file. If you are not configuring anything, by default, what is the block size it takes?
128.
128 MB it takes. But I doesn't want 128. I want some different block size, like 100 or 50. I want as the block size, or like 30. I want as the block size.
Can I make it more than 128?
Yes, yes. I'll say right whether it's advantageous or disadvantageous. Yes, 1 second. So here, okay, I can make a 200 also, 300 MB also. You can whatever you want. We can increase or decrease the block size. We can set our own block size. So for that configuration, property and close property, name distributed file system dot block size. What is the value? 50 MB, right? Okay. Default. Okay, you can set your own block size in this way. Now it is set to 50 MB means, so whenever a new file comes, divided into 50 MB blocks. So it is going to be divided into 50 MB blocks, right? So in Hadoop, data is stored in the form of files. The files again subdivided into smaller parts called as blocks. Default block size 128 MB or 64 MB. But if you want to configure our own block size, you can just set this property and set it. Now, data storage and processing. Data storage and just now some query was asked, right? Yes. Just now some query was asked. What is advantageous? Which is advantageous? Having bigger default block size or smaller one? Try to answer everyone. We can set our own block size. I'm saying which one will be advantageous? Having bigger default block size or smaller?
Based on the requirement, we can set.
Smaller may make more memory saving because
Observe. We'll take one example of bigger and one smaller and try to comment on it. First, if I take f1.txt, assume the file size is 900 MB. 900 MB is the block size. Sorry, file size. Default block size 500 MB. Means this 900 MB is divided into how many blocks? 2, right? If your default block size is 500 MB, so this file is divided into 2 blocks. 2 blocks. B1 stored in S1 of 500 MB. S2 of 400 MB. Yeah, some answer was given, right? Bigger block size is best with respect to access span. Okay, I'll come back to it. What is that in the case of bigger block size? Okay, assume. So here totally how many blocks? Everyone, I want the sessions to be interactive. Everyone try to respond. You can unmute yourself and give your responses. Here totally 2 blocks, 500 MB default block size. So this 900 MB file is divided into 2 blocks. The 2 blocks stored in 2 systems. Here 2 systems are running parallelly for executing this f1.txt. For running this f1.txt file, how many systems are running parallelly? 2 systems. I'll give a labor example. A building construction. You got 20 labors. You brought 20 labors, but you are given task to only 2 labors. They're running parallelly. If I given the same work to 20 labors, it should have been completed fast. In the same way, if you have got 40 node cluster, 40 node systems you got, where you are using only 2 slaves, less speed. Instead, if the block size was 64 MB, instead of 500 MB, if the default block size, if the default block size 64 MB, nearly 15 slaves will be running parallelly. More speed, right? Understanding everyone? Hello?
Yes, sir.
Yes, sir.
So here you got more systems, but you are not utilizing all the systems. Only 2 systems running parallelly to executing this. If more systems running parallelly, more speed you should have achieved. But if I keep 900 MB as a default block size, only one system running it, only that system only executing the entire data, right? So what is the drawback of bigger block size? Understood everyone? Why Hadoop is keeping 128 MB as the default block size? Understanding? Hello?
Yes, sir.
Assume, okay, someone said just before, if we keep smaller block size, it may be advantages. Okay, we'll take example on smaller, a file of 50 MB. In Hadoop, data is stored in the form of files. The file size is 50 MB. Default block size 5 MB only. This 50 MB is divided into 5 MB, 5 MB blocks stored across 10 systems and processed parallel. A small file of 50 MB, it's divided into smaller parts again of 5 MB blocks and stored across multiple systems and processed. A small file divided into smaller parts again computed and the output is collected. It's a time-taking process. Already the file is a very smaller file. Again dividing into smaller parts, again storing in systems, processing it, again retrieving the results. It's a time-taking process. If 5 MB or 10 MB if you are keeping, right? Understood the drawback here? Hello?
Yes, sir.
Drawback here is, so the block size should not be too big or too small. So in latest versions, default block size is given as 128 MB. Okay, you can keep your own block size as per the requirement, right? But too big is not recommended, too small is not recommended. See now how exactly the data storage and processing is happening within Hadoop.
Sir, one thing, if we take a bigger block size, in that case, if we have a more computing device at that point of a time, we are wasting our computing machine. But if
See,
a block size is
what is that? I want to achieve speed. What is my concern? Why I'm going for this? I want high speed, huge data, high speed. For
the
example,
processing time will be more.
for example, I've taken a smaller file, but Hadoop is good for huge data. Hadoop is bad for small data. For example, to show you, I've taken a smaller file and I was just showing that example, but a very big file stored across multiple systems and processing. If you are utilizing more systems, more speed you are going to achieve, right?
Yes.
So if you have got many systems, but you every time you are running on 2 systems or 3 systems. Speed is less. Only 3 systems running parallelly. Some tasks will be in the waiting state. Okay. For understanding those, for understanding that, see that how data storage and processing is happening. I'm going to discuss 3 cases here. Case 1. Number of blocks equal to number of slaves. If number of blocks equal to number of slaves, 4 blocks, 4 slaves, full parallelism, very high speed. Case 1. 4 blocks, B1, B2, B3, B4, 4 slaves, S1 to S4. F1.txt, 240 MB. F1.txt, size 240 MB. Default blocks, assume 64 MB. Assume it's 64 MB. Into how many blocks this file is divided means 240 by 64. 4 blocks means B1, B2, B3, B4. Observe here, this is the master node. In that we got name node. And here these are the slave nodes, 4 slaves. B1 stored in S1, B2 in S2, B3 in S3, B4 in S4. Master node, name node, they stores metadata information. They stores metadata. They stores metadata information, right? But this slave stores the actual data. Blocks and slaves. B1, B2, B3, B4. F1.txt divided into 4 blocks. 4 blocks stored across 4 slaves. 4 blocks stored across the 4 slaves. Assume how exactly the data storage and processing is happening, right? So case 1, number of blocks, if it is equal to number of slaves. How many blocks? 4 blocks. Assume 4 slaves. B1, B2, B3, B4. Slaves how many? S1, S2, S3, S4. Number of blocks, if it is equal to number of slaves, very high speed, full parallelism. Assume f1.txt, f1.txt, f1.txt. What is it? 240 MB. Default block size. (64 MB). Into how many blocks, number of blocks it is divided. File size by default block size. 240 by 64. 4 blocks. 4 blocks. B1, B2, B3, B4. B1 stored in S1, B2 in S2, B3 in S3, B4 in S4. So observe, this is the master. These are the slaves. Single master, multiple slaves. S1, S2, S3, S4. B1 in S1, B2 in S2, B3 in S3, and B4 in S4. B1 in S1, B2 in S2, B3 in S3, and B4 in S4. Here, this is the master node. Within the master node, we see name node. Name node stores metadata. Metadata means data about data. It won't store data, but metadata information. For example, f1.txt file into how many blocks it is divided, where each block is stored. B1 in S1, B2 in S2, B3 in S3, B4 in S4. This is how exactly the data storage is happening, right? File divided into blocks, blocks distributed across slaves. And if you talk about the processing, data processing. In Hadoop, job is to process f1.txt. Job is always divided into blocks. Sorry, job is always divided into tasks. Job always divided into tasks, number of tasks. Number of tasks always depends on number of unique blocks. Number of unique blocks. How many unique blocks here? 4 blocks. Number of tasks equal to number of unique blocks, 4 blocks. So as there are 4 blocks, 4 tasks. 4 tasks. Understand here in Hadoop, the number of tasks always depends on blocks. If 4 blocks means 4 tasks. 10 blocks means 10 tasks. 2 blocks means 2 tasks. So here 4 tasks, T1, T2, T3, and T4. Understand here, job is to process f1.txt into how many? Job f1.txt. T1, T2, T3, T4. T1 is for executing B1. B1, assume that we have got 10 lakh records in this. B2 also has got 10 lakh, B3 also has got 10 lakh records. T1 task is for executing B1 10 lakh. T2 task for executing B2 10 lakh. T3 task is for executing B3 10 lakh. T4 task is for executing B4 10 lakh. T1 task for executing B1, T2 for B2, T3 for B3, T4 for B4. Who should execute this T1 task? Which system? T1 task is for executing B2, T2 for B2, T3 for B3, T4 for B4. B1 has got 10 lakhs, B2 has got 10 lakh, B3 has got 10 lakh. So who should execute the T1 task? Which system should execute the T1 task? Hello. Among
S1.
S1 only, right? S1 only can execute because B1 block, T1 task is for executing B1. B1 is present in S1, S1 only can execute it. Who should execute T2?
S2.
S2 only, because B2 is present in S2. So S2 only should execute T2. T3 by S3 and T4 by S4. So here, 4 tasks. Here 4 tasks T1, T2, T3, T4 are executed parallelly. Four tasks are executed parallelly by 4 slaves. S1, S2, S3, S4. That's why we say high speed, full parallelism, right? Understood this? This how storage and processing is happening.
Yes.
Hello?
Yes, sir. Understood.
Yes, sir.
Observe this case 2 now. Observe this case 2, everyone. Case 2. If the file divided into blocks, if the number of blocks more than number of slaves, how many blocks? 4 blocks. How many slaves? 2 slaves. B1, B2, B3, and B4. How many slaves? Number of blocks 4, number of slaves 2. Okay. F1.txt. I got a file f1.txt. Assume it's 240 MB. Default block size. 64 MB. Into how many blocks it is divided? Number of blocks. Okay, 240
4
by
blocks.
64. How many? 4 blocks.
Sir, is this the first class of Big Data Hadoop? Hello?
Yes. So before this, we had some introductory session, right?
Yeah, last week I have attended the demos.
After that,
Just
this is the next class after that.
okay.
So here number of blocks 250, 240 by 64, 4 blocks. 4 blocks, but only 2 systems, 2 slaves, S1, S2, S1, S2. Here B1 here, B2 here, B3 here, B4 here, B1, B2, B3, B4. This is the name node. Within the master node, we have got name node. Name node, what is that? Name node stores metadata information. It stores metadata information. This f1.txt, f1.txt, it is stored across f1.txt, stored in, divided into 4 blocks, B1, B2, B3, and B4. B1 in S1, B2 in S2, B3 in S1 again, B4 in S2. This is how the data storage. But data processing, you observe, data processing. You see the processing, right? Job to process. Okay. Job to process f1.txt. Always the job divided into tasks. Into how many tasks? Number of tasks in Hadoop always depends on number of unique blocks. It always depends on number of unique blocks. How many blocks? 4 blocks. 4 blocks means number of tasks also 4. T1, T2, T3, T4. Now, observe here, right? Job.
Excuse me, sir.
Yes.
Is this 4 blocks constant for every file we get?
No. The number of blocks depends on the file. 240 by 64 means you got a file of so and so size. Default block size, it is divided into 64 MB blocks. 240 by 64 means 4 blocks. If the file size is 900, how many blocks you will get? Approximately 9 to 10 blocks. If the file size is 1500 MB,
Okay.
you will get nearly like 25 to 30 blocks. So here depends upon the means your file is divided into fixed size 64 MB blocks. Here 240 means you will get 4. If it is somewhere like 800 means like you will get like 10 blocks.
Means exactly this 64 does not divide 240, no, sir. Like if it is 256, then it is 4 blocks.
So I said just before, right? Yeah.
Okay, got it. Like if any number of
B1,
big file, it
B2,
will be divided into
S1, S2,
small
S3,
blocks.
S4. All the blocks will have equal value except the last one, 8 MB only. 200 MB means 64, 64, 64, 192. The last block has got 8 MB only. All the blocks will have equal value except the last block.
Okay. I'm sorry. I did not attend the class in the initial 10 minutes, that is it.
All right. Every file will have, all the blocks will have equal value except the last block. For example, if it is 220 means 64, 64, 64, 192. And last block will have 28 MB. Now.
Okay. Got it.
Job to process f1.txt. How many number of tasks always depends on number of unique blocks. How many unique blocks? 4. Sorry, 4 unique blocks means 4 tasks. Job to process f1.txt into 4 tasks. T1 task, T2 task, T3 task, T4 task. T1 task is for executing. It is for executing which one? B1, 10 lakh records.
V1.
T2 task is for executing B2, 10 lakh records. T3 task is for executing B3, 10 lakh records. T4 task is executing for B4, 10 lakh records. Who should execute this T1 task? Everyone.
F1.
Who should execute T1?
S1.
S1. Who should execute
S1.
T2? T2.
Yes, 2.
S2.
S2 because B2
S2.
block B2 is present in S2. S2 only should execute. And T3 task.
Yes, 1.
T3.
S3. I'm sorry, S1, S1.
B3 block is present in S1 only. T4.
S2.
T4 means
S2.
T4 is present in S2. S2. Observe here. S1 here. S2 here. S1 executing how many tasks?
2.
Which are they?
T2
T1,
and T3.
T3. S2 executing how many?
T2,
T2,
T4.
T4.
T2, T4, 2.
But here when T1 is executing in S1, T3 will be in waiting state, right? T1 when it is executing in S1, T3 task will be in the waiting state or not?
Yes.
When T2 task is executing in the system 2, T4 task will be in the waiting state. Once T1, T2 gets execution finished, then only they can execute T3 and T4. Means here some tasks are in the waiting state, right? Some tasks are in the waiting state, right?
Yes, sir.
So you can see less speed. If number of blocks greater than number of slaves, less speed. Oh, understood this? Some tasks are in the waiting state. Now observe this case 3. More blocks. Single slave. More blocks. Single slave. 3 blocks. 1 slave. B1, B2, B3. 3 blocks. Single slave S1. B1, B2, B3, yes. F1.txt file, F1.txt. Assume the size somewhere like 192 MB. Default block size. Default block size. How much? 64. Assume it is 64 into number of blocks into how many blocks? 192 by 64. 3 blocks. 3 blocks means B1, B2, and B3. How these 3 blocks are distributed across these slaves? Only one slave, right? This time only one slave S1. B1 here itself, B2 here itself, B3. All the blocks are stored in the same slave. This is the name node. Stores metadata. F1.txt into how many blocks? B1, B2, and B3. B1 in S1, B2 in S2, B3 in S3. sorry, B1 in S1 only, B2 also in S1 only, B3 also in S1 only. This is how the storage happens. Data processing. Job to process f1.txt into how many tasks? Number of tasks in Hadoop, always number of unique blocks. You may ask why the name unique. I'll say in the next example why we are using the word unique. How many unique blocks? 3. 3 blocks, 3 tasks, T1, T2, and T3. Job to process f1.txt. T1 task, T2 task, T3 task. T1 for executing B1, T2 for executing B2, T3 for executing B3. Who should execute this T1 task?
S1, sir.
T2,
S1,
T3,
S1.
S1. All the 3 tasks here, all the 3 tasks, T1, T2, and T3. Here all the tasks T1, T2, and T3. Here all the 3 tasks T1, T2, T3 are executed sequential, are executed by S1. Here all the 3 tasks T1, T2 are executed by S1 sequentially. Here no parallel processing. Here no parallel processing. Right? Here no parallel processing at all. Means if case 1, number of blocks equal to number of slaves, more speed. If the slaves are less speed. Only one slave, no parallel processing at all. Right? No parallel processing at all. Okay, here, okay, if I go back to this, if I go back to this case 1, go back to this case 1, right? Master node, name node. T1, T2, T3, T4. 4 tasks are executed by, okay, assume 3 tasks are executed by 3 slaves, S1, S2, S3. 3 tasks are executed by 3 slaves, 3 systems. Suddenly, if particular system is down, as they are machines, suddenly if S2 is down, 2 drawbacks you observe here, 2 things you will observe here, right? This 10 lakh B2 block is lost. B2 block is lost means 10 lakh records are lost. If the data is too sensitive like banking data, it's a big loss. That is one. Second thing is T2 task will be failed. T2 task will be failed means job also failed, right? If all the tasks successfully executed, then only job successful. But here T2 task is failed, data is lost, task is failed. Right? Understand here? When multiple tasks are executed by multiple slaves, multiple systems parallelly, suddenly if any system goes down as they are machines, then data is lost, task is failed. So for that, Hadoop comes with a concept called replication and fault tolerance. So clearly I mentioned all these cases here, case 1, case 2, case 3, right? So case 1, what was 4 tasks executed by 4 slaves. Assume each task takes 1 hour. Total time taken for all 4 tasks is 1 hour only. Case 2, 4 tasks executed by 2 slaves only. Assume each task takes 1 hour. Total time taken is 2 hours. First S1, S2 execute 2 tasks. Again S1, X2 execute the other 2 tasks. Fourth, in case 3, only 1 slave means 4 hours for it. So here just now I was talking, right? When suddenly if any system goes down, then you can see data loss and task is failed, means job also failed. Now observe. We have got a concept called replication and fault tolerance. 4 tasks are executed by 4 slaves. Suddenly if S2 is down, we observe 2 things. Data loss, B2 block is lost, task is failed, T2 task is failed. To overcome this, we have got replication and fault tolerance. See, replication means duplication. Default number of replications, replicas in Hadoop 3. You can have 3 replications. Default number of replications in Hadoop is 3 replicas. 3 replicas, right? We can also configure increase or decrease the replications. By default, it is 3. If you want to increase more replications, more duplications, right? You can increase. Later, I'll show you how to increase or decrease the replication. But here, f1.txt 192 MB, default block size 64 MB, number of blocks 192 by 64, 3 blocks. 3 blocks means, observe here, what do you mean by replications? 3 replications means B1 replicated by 3, B2 by 3, B3 by 3, means B1 duplicated by 3 times, B2 duplicated by 3 times, B3 also for 3 times, totally 9 blocks. Observe here B1 block replicated by 3 times, B2 by 3 times, B3 by 3 times, totally 9 blocks. Master node, name node, and this S1, S2, S3. In S1, B1, B2, B3 you can store. In S2 also B1, B2, B3, S3 also B1, B2, B3. Means here in slave 1, 3 blocks, in S2, B3, B3. If talk about this replication and fault tolerance, right? f1.txt 192 MB. Number of blocks 192 by 64, 3 blocks. 3 blocks means B1, B2, B3. B1 replicated or duplicated B3 by 3 times, B3 by 3 times. Totally 9 blocks. Totally 9 blocks, right? Here, this is the master. These are the slaves, 3 slaves. So here B1, B2, B3. B3, B1, B2. B2, B3, B1. 9 blocks stored across 3 slaves. F1.txt into B1, B2, and B3. B1 in S1, S2, and S3. B2 also in S1, S2, and S3. B3 also in S1, S2, or S3. This data storage. Now data processing. Job to process F1.txt into divided into tasks. Always in Hadoop, number of tasks depends on number of unique blocks. Now try to understand the unique blocks here. How many unique blocks here?
3.
Unique blocks are 3 only, right?
Yeah.
Not 9. Means all the remaining are duplicated blocks. Okay. Job to process F1.txt. T1, T2, T3. T1 for executing. T1 is for executing B1. T2 for executing B2. T3 for executing B3. Who can execute to T1 task here?
S1. All the 3, sir. S1,
Yes.
S2, S3.
Not only S1, right? S1, S2, S3.
Two,
Here
three.
also S1, S2, and S3. All these 3. Here also S1, S2, and S3. All these 3 can execute. Okay. All the 3 slaves are eligible to execute T1 task here also. Assume master node has selected S1 only for executing T1. S1 only selected for executing this T1 task. For T2 task, master node has selected S2 only, assume. For T3 task, assume master node has selected S3 only. Yes. Okay. T1 task to S1, T2 task to S2, T3 task to S3. 3 tasks are executed by 3 slaves S1, S2, S3 parallelly. Suddenly, if the system goes down S2, do you think any data loss? Do you see any data loss?
No, sir.
No.
Still that V1, B2, B3 available in the other slaves, right?
Yes.
If S1 also down, still that data available in S3, right?
Yeah.
So even though if the system 2 is down, slave 2 is down, still there is no data loss, and this T2 task will be assigned to either S1 or S3. There is no task failure, there is no data loss. Here I got 2 queries. What is the criteria followed in assigning the task to a slave? Why S1 only selected here? Why not S2 or S3? For executing T1 task, why not S2 and S3? That is one. What is the criteria followed in assigning a task to a slave? That is one. Second, if S2 system is down, then T2 task. If S2 system is down, T2 task to be assigned to S1 or S3. Understand this? T2 task to be assigned to S1 or S3. Okay. S1 executing T1, S2 executing T2, S3 executing T3. Suddenly this is down. T2 task to S1 or S3. That is the query. What is the criteria followed in allocating the task to a slave? 4 steps criteria. 4 steps criteria. First one. Master node selects the slave which is highly configured, means which has got high hardware configuration. Assume both have got equal configuration. Both have got equal configuration. Then master node selects the slave which is more ideal. More ideal means more free. S1 executing 5 tasks, S2 executing only 2. So assign to S2. Assume both are free. Assume both are free. Both are not executing any task. Then master node selects. Master node selects the slave nearest to it. Means master in one country, slave in another country, master in one state, slaves in different states, master in some city, slaves in different cities. Or assume master node selects the slave nearest to it. Assume both are equally near. All are in the same lab. Both are equally near. Then master node selects the slave which has good health status. Assume both has got good health status, means both has good health status. Assume both has got good health status. In the extreme case, it selects any one slave randomly, right? This is the criteria followed, right? This is the criteria followed. Just observe this. Given clear notes for it. What is the criteria followed in assigning the task to the slave? Right. Master node selects the slave which is highly configured, which has a high hardware configuration. If master node selects the slave which is more ideal, which has nearest to it. What do you mean by fault tolerance? If multiple tasks are executed by multiple slaves, suddenly if any one slave goes down, then the task will be assigned to the available slaves. This process is called fault tolerance. We can also configure, right? Increase or decrease the replications. See, Understood this fault tolerance? Multiple tasks are executed by, if any slave goes down, then the task of it will be assigned to other slave. That is called fault tolerance. And we can also increase or decrease the replications. By default, 3 replications. If you want the same, go to that hdfs-sci.xml where you have configured the block size. So this is the property, first one for block size. Same thing you copy paste. dfs.replication, dfs.replication. How many? 4 replications. Or 5 or 6. If data is more sensitive, go with more, right? So yes. Design principles with respect to replication. Replication applicable only for data but not for metadata. Replication is applicable only within the slave but not in the master node. All the same replicas cannot be within the same slave. See, in S1, B1, 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 S2, B2, 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 in S3, right? Suddenly, if S2 is down, there is no B2. Okay.
If
B1, B1, B2,
replica,
B2, 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 B3. If suddenly if S2 is down, B2 data is lost. So same replicas cannot be in the same slave. Maximum number of replications means how many slave nodes you have got, those many replications you can have. So just now I was talking which is advantageous. Having a bigger default or smaller means no, both has got drawbacks, right? So this is what it is. Okay, see this from the starting clear notes I'll be forwarding you, right? Databases, HDFS, how exactly data storage.
hello sir.
Yeah,
Let's say you told that master node is not replicated. In that case, if master node itself fail, in that case, what happens?
yes, a good query. Yes, see if one slave fails, please be in mute. So if one slave fails, then the control, that is the task will be assigned to other slave. If master itself is down, the entire cluster will be in spectator mode. You cannot perform any storage or processing. So you cannot perform any kind. So if whenever master node is down, then we have got a secondary name node. There is a concept of secondary name node here also. Just like in the absence of principal, we have vice principal. Here also in the absence of master node, immediately secondary name node comes into picture. What is secondary name node? What are its responsibilities? That I'll be discussing right in this architectural part. So next in that tomorrow's class, I'll be discussing about architecture, Hadoop architecture, storage architecture and processing architectural components. How exactly the storage architecture and processing architecture. So with that, I'll go with the practical part. Tomorrow, if I discuss that architectural part, storage and processing architecture, and we have got a concept of job tracker, task trackers previously. Fine. So yeah, so you can go through that course content, right, of totally PySpark, main concentration on PySpark. So introduction to big data, HDFS, MapReduce, Scoop, Yarn, NoSQL database, HBase, NoSQL data, and Hive. We have got a lot of discussion on Hive, working with different data, XML, JSON, URL, weblog data, and PySpark. Mostly we have got there's a lot of discussion on PySpark. PySpark RTD computations, persistence options, PySpark core computing, grouping segregations, various actions and transformations, PySpark SQL data frames, various data frame APIs, PySpark SQL functions, PySpark built-in functions, PySpark external sources, Spark and Hive integration, Spark and MySQL integration, working with CSV files, working with JSON files, deployment mode, local mode, cluster mode, PySpark applications, stages, tasks, deploying Spark applications to cluster and performance tuning, PySpark streaming, integration with Kafka, PySpark machine learning library, right? It's everything, right? So I said, so it's for those who want to go for Hadoop, PySpark, Python, and Linux. The fee structure is 15,000, right? For Python, you can attend any of my weekday batch, Monday to Friday. And for this Hadoop PySpark weekend, right, Saturdays and Sundays, 2 hours on Saturday, 2 hours on Sunday. So tomorrow you can attend the session, right? But tomorrow the link will be changing, right? So everyone need to get enrolled, right? For getting that link for tomorrow's session, right? Fine. So you can see in the chart. You can see in the chart, right? Yes.
Can I get the syllabus? Is it possible?
Okay, 1 second. 1 second. Give me a second. Right.
Sir, any weekday batch, sir?
As of now, no. Most of the batches are on weekends only.
Okay, sir. Weekend, how many hours, sir? For Sunday, Saturday?
2 hours on Saturday, 2 hours on Sunday. Right.
Okay. That is evening session.
Yes, you know.
Okay, sir.
Hello, sir. You mentioned something, the weekday classes, right? For which one is that? Python?
Okay, that is for Python. You can attend for Python. You can attend any of my batch of, right? Python for Python, right? If those who are attending who wants this. See, I said if you have already got knowledge on, so the fee structure for this is 15,000, which includes Hadoop, PySpark, Python also, like nearly 1.5 month of Python classes also included in that. For that with Python, right? It's 15,000. Without Python, it is 12,000, right? So Python, you can attend any of my regular weekday batches, Monday to Friday. Mornings are available, evenings are available. So you can.
So are you saying that Python is not covered in this class? We have to take another class.
No, actually in weekend means Python will be from Monday to Friday, I must say, not in the weekends.
Right. So it is not covered in the weekend batch,
It will be in
but
the
it will be covered in the weekdays.
weekdays. Either you can attend morning or evening batch. Both are running. Many multiple batches of mine are running, right? Still, okay, if you're unable to attend in the weekdays, right? So most of the students who enroll for this big data, either they'll be attending live classes of Python morning or evening, or even sometimes the students will be following the videos, and some days they'll attend and they will clarify the queries, right? If unable to attend.
Sir, morning at what time?
Okay.
Python, evening or?
Morning from Monday, day after tomorrow, at actually at 5 a.m. it is, morning 5 o'clock it is.
Okay.
For first 4-5 days, it will be at 5 o'clock. Later, it will be at 6 o'clock up to the end of the course. Python.
Okay.
And
5 a.m., sir.
5 a.m. in the morning. For the first 4-5 days, it will be at 5 a.m. But later, it will be at 6. Starts at 6, right? 6 to 7.
Okay.
And
Sir, where can we get this today's notes? Today's class notes?
yeah, I'll be forwarding. What is it? Today's notes. See, yes, tomorrow a WhatsApp group is going to get created. So yes, that's what I'm saying, right? Tomorrow you'll be getting all the videos to your Google. Those who have already got enrolled, check your Google Drive, right? You can see that videos. And tomorrow a WhatsApp group, you'll be get enrolled. Those who got enrolled will be added to that WhatsApp group. Notes will be forwarded. Videos will be forwarded to Google Drive. Notes will be forwarded to your WhatsApp. And a new WhatsApp group will be created. And software also. Next, I'll be demonstrating about the software. Software also will be forwarded to your Google Drive, right?
Any
I have
course
already
only with the
enrolled, but I have
PySpark
not got
and
the videos.
You didn't get?
I have already enrolled, but I have not got any notes in my shared drive notes
No,
or any video.
notes. I'll be
Even
forwarding. Once
even
Video is
myself
also not
also not
showing
got.
there.
it was introductory session, that still notes was not forwarded. So yes.
And even
One
myself
second.
also I not got the
One second.
drive.
One second.
I have one question. Okay, do you have any course like a Spark and PySpark only, not the Hadoop includes? Hello, I'm audible.
Just 1 second. 1 second. Yes.
Sir, can you share the today's class notes?
Yeah, 1 second, 1 second. Yes, 1 second. So you can see a big message is given, right? Once again, I forward it.
This class started 4:30 p.m. IST or 5 p.m. IST?
4:30, right?
Okay.
Sir, the
One
timings
sec,
will be
one
the
sec,
same,
one
sir,
sec,
for the
one
rest
sec.
of the course. Are
Yes,
you
yes,
planning on switching
yes.
it to a different time?
No, it starts at 4 o'clock.
4 o'clock, not 4:30.
Yes,
Sir, tomorrow the class will start at 4 p.m. only.
4:30 it starts tomorrow.
Okay.
Later
So
once, yes.
now it will be 4:30. So next week it will be 4.
4:30, yes, yeah. 1 second. 4:30, right? Tomorrow it will be at 4:30. In the next coming days, right? Like 4 it will start. 4 to 6.
No, Vijay, one request, right? See, I'm in EST. 4 o'clock is like 5:30. So you wanted to keep it still to 4:30? I'm
4:30,
not sure. I
okay.
just
It's fine that 4:30 will be fine. 4 or 4:30 if anything is fine. That okay, we'll continue with 4:30 only. Tomorrow 4:30, next week also we'll go with 4:30 only, right? Yes. Okay.
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 Yes. Uh,
Sir, Monday Python evening class at what time, sir? Evening classes, sir, you
But-
are saying.
Okay, 1 second. I will come to it. So now you can see a message is given by this online team, DURGASOFT. See that course content for this total big data course content is given. And yes, the payment details also forwarded, right? Yes.
Hmm. Hmm.
Sir,
1 second.
నా దగ్గర ఇది ఈ రెండు ఉన్నాయి మామూలు ఫోన్ లేవు కానీ ఒకసారి వెళ్ళి ట్రై చేయండి
Any queries, right? So to get enrolled. So just to get enrolled, right? So tomorrow a WhatsApp group will be created. So if you got any queries or any errors, you can just take the snap and you can post in that WhatsApp group. And from tomorrow onwards, you can see the videos in your Google Drive, everyone for all that. And notes I'll be forwarding, videos will be shared by this DURGASOFT team. Yes, software I'll be forwarding to your Google Drives. Yes. So all the
but
sessions, all the
Sir,
sessions.
what software we need to install for big data?
So big data I'll be providing, right? I'll be providing some VMware image, right? Where you can see all the components of Hadoop and PySpark, right? And I'll be also showing you in different environments in Anaconda distributions, Jupyter Notebook. Yes. And someone was asking evening Python batch.
yes, sir.
Yes, from Monday it will be. Please be in mute. Monday, right? It will be at 7 p.m., right? So 7 p.m. it starts. For the first 4 or 5 days, it will be at 7 p.m. Later, it will be at 8 p.m. right in the evening. Okay. And this present batch, like 4:30 to 6:30 is the time for the current batch. That is a weekend batch. Yes. And you can see in the course, the chart panel, right? The course content details, the payment details through like Google Pay or FinPay.
Payment details, right?
Payment,
Vijay,
payment details they have pasted in the chart, right? The online team they have pasted in the chart. You can see
just now okay, I see that. Sorry, my bad.
and people, what happens is tomorrow to get the link, you can check your mails, right? You can check your mail IDs. You'll be getting a new link, right? And don't forget to share the screenshot of your payment to DURGASOFT online training, right? @gmail.com. DURGASOFT
Okay.
online training @gmail.com, right? Yes. Then only they'll be forwarding you the link, right?
Sure. I have one question. So basically on the weekends, you're covering Hadoop and PySpark.
Yes.
And for Python, it should be weekdays. And
Yes.
what about Linux?
Linux weekends only.
On the?
Weekends only. Before I go with the practical, first I'll be covering all. In weekends only it will be.
Okay.
Except Python, remaining all will be in weekends only. Python core and advanced, everything in brief, it will be covered. You can see the course content of this Hadoop also, right? Sorry, Python. You can see that Python course content. Python basics, operations, operators, IDs, flow controls, loops, strings, collections, lists, tuples, sets, dictionaries, functions, modules, packages, exceptions, file handling, object-oriented programming features, regular expressions, database connectivity, Python datetime, OS, advanced concepts, GUI, Excel, working with Excel files, data analytics, introduction to data science, Pandas model in brief, NumPy model in brief, Matplotlib model in brief, right? This is what the entire Python for an advanced, right? Yes.
This Linux part will be
Okay.
like, hello, hi, Vijay sir. I have paid like 12,000
The Linux.
and I have paid 12,000. So how it will be for me? Like this big data, whatever is there for big data and Hadoop, I will be covered. But
Hadoop,
the Linux, yeah.
Hadoop, PySpark, and Linux, right? Except Python.
Okay, okay. So, but you have written that it's 15 weeks. So I'm not sure. You are covering the this part, big data, Hadoop, PySpark, and Linux in the weekend.
Yes, yes,
So,
yes.
but there is one confusion with the 12 week and 15 week. As you were saying that Python will be totally in the weekdays.
No, 1 second. So like it will be like 12 weekends. Totally all this will be of 12 weekends. 3 months it will be 12 weekends.
Okay, so 15 weekends is not actually.
Actually previously that Python also used to be in the weekends. It was they used to give that. So it's not like 12 weekends only.
Okay, weekend is 12 only. Okay, okay.
12 weekends it will be. And Python will be in the weekdays, right?
Actually, the timing is not matching. If I am also eager to join the Python classes, but the timing I am not comfortable with. If the timing was after 10 p.m. Indian time or like after 10 p.m. maybe
10 p.m. in the night.
Yeah. If you have any class in that time or
8 p.m. is not fine.
Most of the time, I don't come back by that time from
8 to
office
9.
actually.
Morning,
Morning, maybe from 7 to 9, I'm free. Morning.
in the coming days, there is a 8 to 8 a.m. batch will be starting. 8 to
Okay.
9, 8 to 9, 8 a.m. to 9 a.m.
Okay. Okay.
Yes.
Okay. So once
So,
it starts, please let me know in that case.
It will be kept in your WhatsApp group, right? In all the groups.
Okay.
sir, I am interested in the full coursework, including Python. So, DurgaSoft will be able to hook me up with the right course, right? With the right uh, batch
So you can
for
attend
Python.
any of my Python batch you can attend, right? Morning, evening. If you're not comfort tomorrow, if your new batch starts in different timing, that also any of my Python batch you can attend once you got enrolled, right?
No, sir, I did follow up with DurgaSoft. They gave me one link to join for Mr. Prakash Babu.
Hmm.
The same course with you or somebody else?
Python, I'll be discussing Python, right?
So that's what I'm asking. They sent me a different instructor, so I don't know how should I ask for it.
Have you got enrolled?
No, I haven't yet. It
No.
starts from Monday.
No. That is a different trainer for Python, right? So if you want,
Right.
my batches will be there. My Python batches you can enroll. So you can
So
ask for
can you give me something in the evenings, like around 6:37 p.m. IST times?
7 p.m.
7 or 8.
Day after tomorrow, Monday, 7 p.m. IST, there is a batch starting, right? Python.
Okay. Just
Yeah.
by giving your name, they'll be able to figure it out, right?
Yes, Vijay, you can say it.
Okay.
Vijay,
Sir, I have it.
Yes.
Sir, I have a doubt. We discussed about various cases, how data will be stored and processed, no, sir? Like from where do we get this data?
Where you get this data from means, yes. See, from databases, we'll be pulling the data. Most of the time from different databases, we'll be pulling the data.
Okay. Do we discuss this as a practical in this classes then?
See, only for tomorrow it will be theoretical, but next week onwards everything will be practical only, right? There won't be any theory at all. So we'll be how to pull the data from different databases to this Hadoop environment using a component called scoop, import and exporting data. That I'll be discussing there. In that scoop component, I'll say how to import and how to export. Importing into Hadoop environment and again exporting from Hadoop to the other environments, right?
Okay.
Sir,
Which
does the same
software we need to install, sir, for practical classes?
I'll be demonstrating that and I'll be forwarding that to your Google Drive. You'll be downloading from there. Right?
Okay.
Okay.
Sir, will the same concept that you're explaining holds good for Spark as well? Like we will be able to use this scoop utilities and all with Spark?
Yes.
Okay. Even Spark has the HDFS underneath for storages and all.
Spark is going to read the data from that HDFS. It is going to take the data from HDFS, process it, again stores it into HDFS back.
Okay.
Fine. Okay. So
Sir,
yes.
Monday evening Python 7 to 8, sir, or 8 to 9, sir, 1 hour, sir.
7 to 8 it will be for the first 5 days.
Okay.
First 1 week like that will be at 7 o'clock. Later it starts at 8 to 9 up to the end of the course.
Okay, sir. That is
Sir, is
how
Python
many months, sir?
mandatory?
How many months, sir? Python?
Python it will goes for 1.5 months to 2 months.
2 months. Okay, sir. Thank you, sir.
Sir, for big data Hadoop, is Python also mandatory?
PySpark, Spark with Python, right? Total coding goes in Python, right? PySpark.
I don't know. Like, is PySpark and Python, PySpark and Python both are different programming languages, right? So if one PySpark is enough, we don't need to learn Python again. Is it anything like that?
To know PySpark, you need to have the knowledge on Python.
Okay.
To understand, if you want to understand this PySpark, right, you need to have the knowledge on Python. That's why. So by the time this Hadoop gets completed, nearly 68 to 70% of your Python gets completed. Right.
Okay.
So by the time I start PySpark, you will be weekends, in the weekdays, your Python 70% of your Python gets completed, right? Fine.
Okay.
Okay, fine. So if I'm done with your queries, I'll sign off for now. Meet you tomorrow, right? Same time at 4:30, right? But the link will be changing. Check your mail IDs. Still, if anyone even after you getting enrolled suddenly, if you are not got the link, yes, you can ping on this number, right? I can provide that link.
Yeah, sir, Vijay sir, one small request.
Yes, this is
Because
the number.
yeah,
Okay.
because we are in yeah, some of us are in EST time zone. Please stick to the 4:30 p.m. only, sir.
Yes, yes.
Do not go
okay, fine. That's fine. Tomorrow at 4:30 only, right? Yes. Okay, that is the. So I'm stopping here. We'll continue tomorrow at 4:30. Yes, thank you all for your time. Thank you. Meet you tomorrow. Yes. Tomorrow I'll be discussing about Hadoop architecture, Hadoop storage architecture and processing architecture, right? In brief.